Hello and welcome to Zig's Math Lessons. Let's continue with trigonometric identities and let's take a look at some identity techniques. This is what to do when you don't know what to do. Here are some suggestions. Switch everything to sine and cos. Everything can be expressed as sine or cos. Cotangent, for example, is cos over sine. Tangent, for example, is sine over cos. You can factor a numerator and a denominator and cancel. Add and subtract fractions. Make use of the fundamental identity. Sine squared plus cos squared is 1. Multiply top and bottom by a conjugate. Let's do some examples. Here's a trig identity. Prove it. Draw the line. Take a look at this left side. Let's add fractions. We'll need a common denominator, of course. Add the fractions, and we arrive here. 1 minus sine squared is an expression we're familiar with. That's cos squared. Left side equals right side, and the identity proves itself. Let's go again. Prove a trig identity. Okay. Draw the line. Add fractions. We'll need a common denominator. Perform the addition. Sine squared plus cos squared is 1. Look at the numerator. Sine squared plus cos squared, that's 1. And the identity has proven itself, because left side equals right side. Again, prove a trig identity. Let's take a look at this. Well, draw the line and switch to sine and cos. Already done. Next on the list is factor and cancel. Well, we can factor this numerator and denominator. Using our difference of squares technique and common factoring the denominator, we arrive here, and look, those two factors reduce, and we're left with this. Now we could start working on this right side, turn tangent into sine over cos, and work with that, or we could come down here and say, well, cos minus sine, the numerator can be broken, thusly. And cos over cos is 1 minus sine over cos. And sine over cos is tangent. It matches the right side, and another one bites the dust. Let's go again, prove the identity. Let's go down the list. Switch to sine and cos, already done. Factor and cancel, nothing factors. Add and subtract fractions, there aren't any fractions here to add and subtract. Next on the list is make use of the fundamental identity. In other words, sine squared plus cos squared is 1. So this 1, let's put brackets around this 1 and call it sine squared plus cos squared. Now let's distribute subtraction over these brackets, and we'll get 2 sine squared minus sine squared is 1 sine squared minus cos squared because of the distribution over the brackets. And now, since there's really nothing more we can do to this, we can transfer to the right side and work on it. Tangent is sine over cos. Perform subtraction of fractions with a common denominator, and voila, left side equals right side. And the identity proves itself. Lastly, let's prove this one. Going down the list. Switch to sine and cos, already done. Factor, nothing to factor. Add and subtract fractions, there aren't any fractions to add or subtract. Make use of the fundamental identity, sine squared plus cos squared is 1. Well, we could turn the 1 into sine squared plus cos squared, but it won't help, because then we can't factor. So we'll have to multiply top and bottom by a conjugate. Well, 1 plus sine has a conjugate. It's 1 minus sine x. The conjugate of 1 plus sine x is 1 minus sine x. So let's multiply top and bottom by 1 minus sine x. To do this, we need to go top times top over bottom times bottom. But when we multiply bottom times bottom, it's a product of conjugates, which we know to be a difference of squares. So the bottom, the denominator, has become this. And that's an expression that we know. That's what? That's cos squared. Now the cos and the cos squared reduce, and we have this expression, which is the right side. I'm Ziegelviet B. Stunk. Thanks for watching. If you liked it, leave a like, and if you like the content, please subscribe. Check back daily for updates and new videos, and I'll see you soon.